Hello dear students, a very good morning and a very warm welcome to one and all present or there. As you know, we have completed the previous chapter, that is dual nature of matter and radiation. It's now time to jump on the next chapter, that is structure of atoms. In this chapter, we are going to discuss about something that is indivisible. As you know, from the very previous classes from 7th to 8th standard of yours, you are continuously studying about the atoms. So I hope you would be introduced with the term that is atom. Atom is that indivisible quantity. Indivisible, that means it cannot be divided into more than another parts, right? If I talk about my body, or suppose if I take this chalk, the smallest part of this chalk will be the atom. That means if I am going to break this chalk in number of pieces, the smallest number of pieces that I will be getting will be its atom. An atom will not be visible with the naked eye. Now I just want to tell you one thing, that here from your previous classes you have learned that atom is indivisible. But since the research is going on, our scientist has shown us that atom is not that one which is the indivisible particle. But yes, atom is again can be divided into few parts, you can say. So, a brilliant scientist, his name was Thomson, he gave the model of atom. He said that atom is nothing but a spherical shape structure in which positive charge is spread around and negative charges are embedded in it. So let me just start with the Thomsons model. Here in this chapter we are going to study the number of models, or you can say the different number of models, you can say, or you can say the structure of atoms given by the scientist. Now, when we will be continuing with the sections of the structure of atom, you will be understanding why this concept has been drawback for us, why this concept has been reduced. So, before going further, let me just start with the basic thing, that was Thomsons model of atoms. Now, if I just start with the Thomsons model of atom, I just want you to tell one thing, that atom is that spherical body, you can say, which is neutral in nature. That means if I am saying if it is neutral in nature, suppose this is my atom. Now if I am saying that it is neutral in nature, that means number of positive charge will be equals to number of negative charge. Positive charge will be equals to negative charge. So that means if we are talking about the number of protons inside this atom, that will be equals to number of electrons as well, right? So let me just draw the structure of Thomson's model. According to Thomson, our atoms look like this. This is a spherical body which he called as atom. In this atom, positive charge is spreaded around. The red portion that I have rubbed over here, the chalk that I have rubbed over here, this red portion, it denotes the positive charge. And inside this, let me just draw this negative, negative, negative. These are the negative charges that is embedded in it. This is the structure that has been given by the Thomson. Now this structure was also known as plum pudding model or watermelon, because this structure looks like a watermelon, all red, and inside that seeds are embedded. Or we can say this plum pudding model because this is like a pudding in which plums are embedded, right? Now, here the scientist has given his model, that is Thomson's model. His student, whose name was Rutherford, has given another model of atom because he finds some drawbacks, you can say. He finds some drawbacks in this model. We will be discussing about the drawbacks in the later section where we will be studying the Rutherfords model, because if I am going to tell you the drawbacks over here, then you will be saying, how do you know that this was a drawback? But actually what happens is that, what happened when Rutherford started studying about the structure of atom, he faced something that is opposing this structure of atom. So at that time we have found some drawbacks of this and we have jumped to the structure of atom given by the Rutherford. Now after knowing about this, we will be studying about the Rutherford's atomic model. And let me just tell you, for this chapter, structure of atoms, the JEE Main, JEE Advanced, NEET, CBSE, this is an important chapter of modern physics because you are going to see number of questions based on the energy levels that you will be studying in the Bohr's atomic model. But before jumping to the Bohr's atomic model, we will be learning about the basic, how did we reach to the Bohr's atomic model. Firstly, this Thomsons model of atom came into limelight, and then Rutherford has experimented on a gold foil and then he showed the structure of atom. I will be now drawing the Rutherford's atomic model. Rutherford's atomic model. Now what Rutherford did was, he just took a sample of radioactive sample, say beryllium. He took beryllium over here. I should not say radioactive substance, I just say that he took beryllium and then he placed this in a, you can say, closed vessel, right? Now from here he had allowed this beam of, you can say, beryllium, because we wanted the alpha particles out from here. So a source of alpha particle has been placed inside this. I can just write it as source of alpha particle. This was the experimental setup of Rutherford's experiment that I am going to draw before you. Now over here he had applied two slits to collimate the beam. What do we mean by collimating the beam? If we want the beam to go into straight path without any deviation, then we just do the collimation. So he has applied two slits over here so that this beam should be collimated, and this beam has been then allowed to fall on a gold foil. This was a gold foil. Okay, this is a gold foil. Now when the ray has been passed to the, or you can say the alpha particle has been passed through this gold foil, there was a zinc sulfide detector. Because now here you have to understand one thing, when the alpha ray was coming and hitting to this gold foil, he observed one thing over here. Some alpha rays were, or alpha particles were going like this, deviated. Few were going straight and few were coming back just at 180 degree. Now how do you know that these are alpha particles and nothing else? Because zinc sulfide is that alpha particle detector. Whenever the alpha particle is going to be fall on zinc sulfide detector, it is going to show some fluorescence. So this was the concept of finding the alpha particle when it is going through a thin gold foil. Now what you have to focus over here, this was a thin gold foil, not a thick gold foil. Okay. So now when alpha particle was going through this and they got deviated from their paths, some were going deviated like this at a wider angle, some were deviated at a lower angle, and few were deviated at exact 180 degree. They were coming back. So at that time it was observed that if, according to Thomson model, let me just redraw the Thomson's atomic model. If this is the Thomson atomic model, this is a positively charged sphere and negative charges are embedded in it, then how can it allow the alpha particle to go through this? Or how can it allow the alpha particle not to be, or you can say, reflected by this at 180 degree? Because alpha particle, as you know, is the more charged particle than this, or you can say the heavier particle than electrons. If you are having electrons with you and some alpha ray will be coming, so definitely it is not going to affect the alpha particle, because alpha particle is having higher mass. So at that point there was a controversy that how can it happen that this type of results can be obtained. And also on the basis of this experiment, a graph was drawn. That graph was between the number of particles n, that is number of scattered particles, and the scattered angle. Theta. So this graph was something like this. That means if theta is increasing, number of scattered particle would be decreasing, or vice versa you can say, if number of particles will be increasing, theta will be decreasing. Here also happened the same. Now one by one we are going to discuss the cases that happened in this experiment. So to begin with this, I am going to rub before this, I am going to rub this, and we are now going to study the number of cases that happened in. Firstly, it was observed that if it is a atom and here it is a, we earlier didn't know that there is something very higher mass, very compact thing of higher mass at the center of the atom. But when we have seen that few particles were going like this, this was the very frequent case. Now this frequent case has given some inference to us, and that inference is that suppose this is something that I am having in my hand. If I am passing a ray through it and it is going across this body, then what does it mean? That means there is nothing inside that. It is vacant inside. It is empty. So here also the conclusion was same. If the rays are passing, if the alpha particles are crossing like this, that means most of the space of the atom are empty. Most of the space in atom was empty. Now this second observation, these are all observations, and along with that I am writing the inference out of this observation. Now second observation was that suppose this was atom again, what was happening then? A ray was going straight. Okay, I did a mistake over here, and that mistake is that the inference of this observation should not be like this, because this is the inference of that. Inference of this is that because this is alpha particle and it is going to be deviated, it is being deviated from its path. The original path of this alpha particle was this, but it has been deviated at a particular angle theta. What should be the reason? The reason should be that there is something positive, at the center of the atom. and at last we give a name to that central part, we called it nucleus, right. So earlier we know about the protons and neutrons, that this is present inside the atom, but we didn't know about the nucleus. So after this experiment, one thing also came into limelight, that was the nucleus, and we got to know that nucleus is something that is having positive charge inside it. So first thing that we got to know from here is that there is something positive at the center of the atom. Why we are saying so? Because positive always retards, they don't attract each other, they always repels each other. So that means because alpha particle is the one that is having positive charge, if it is going to be retarded from here, that means there is something positive at the center, right. So now second, if I talk about the second observation, it was that all the particles, or you can say many number of particles, were going straight. That means most of the space of atom is empty. Empty. Now if I talk about the probability, it was a frequent case, or you can say this was rare case, because frequent case was the one it was a rare case. So now if we are talking about the frequent case, the most frequent case was the one, that means there was no deviation, they were going straight, and that means most of the space of the atom is empty. Now if I jump to the third observation of the Rutherfords experiment was that, suppose this is the atom, this is the nucleus. Now what was happening there? If the atom is coming directly straight towards the center, that means towards the head of the nucleus, then what will happen? It will retrace its path, or you can say it is coming back and retracing the path of, or you can say the deviation is of 180 degree. The path should be like this, but instead of going straight, the angle has been taken the form of like this. So that means 180 degree deviation is taking place over here. So retracing of path, and this was a very rare case. This was not the frequent case, very rare case. Now the inference that I can draw from here, if my alpha particle is coming back and retracing the path and deviating at 180 degree, then that means there is something that is very much heavier, that is having very much high mass, is placed inside the center, and that we finally called as nucleus. So inference from here will be a very higher mass, but it is very compact in size. Why we are saying so? Because you have seen most of the space of atom is empty. That means there will be some compact body that is present inside the core of the atom. So a very heavier mass and a compact body having positive charge. Why positive? Because as I have told you that positive are repelling each other, because the alpha particles are taking deviations from their path. That means there is something positive inside the center of the atom. So very heavier mass, compact body having positive charge is placed at the center of, is present, you can say, is present at the center of right. These were something that were the observations and inferences that we have drawn from the Rutherfords atomic model. Now we got to know the structure of atom in our mind. how do the atom look like and what are the positions of electrons. So if I just see, let me just tell you what we have discussed in the chapter. We have read about the Bohr's model, we have read about the energy levels, Bohr's quantization energy, so that we are going to cover over here and nothing else, right? So the question number 1 says that in hydrogen and hydrogen-like atoms, as my dear students, I have already discussed what are hydrogen-like atoms. Because hydrogen, as you know, hydrogen is what? 1H1. And if I am talking about hydrogen-like atoms, that means their atomic number is going to be differed by something. That will not be 1. Their atomic number will be something else. So, in hydrogen and hydrogen-like atoms, the ratio of difference of energies E4n minus E2n and E2n minus En, it varies with the atomic number Z and principal quantum number n. So we have to tell them what will be the ratio. Let me just tell you one thing. We have read one important formula of energy in this chapter, and this is nothing but, let me just tell you, this is E. If I will be writing in the form of En, that will be En equals to E1 upon n square, isn't it? Let me just tell you, we were writing E equals to minus 13.6 by n square, right? Now if I just want to find out the E for second shell, third shell, that will be E1 equals to 13.6 upon 1, right? E2 will be 13.6 upon 2 square, that will be 4. So can I write this E2 as E1 upon 2 square? So definitely it is going to be converted into this form if we are going to write it for n. So that means we are having En equals to E1 upon n square. So let me just start with the question now. We have been given E4n minus E2n. Now if I will be writing for E4n, that will be E1 upon 4n square, right students? And if I will be writing for E2n, that will be E2n equals to E1 upon 2n square. So my E4n will be E1 upon 16n square and E2n will be E1 upon 4n square, isn't it? Right? Now what I have to do? We have to take the difference of them, and also I have to take the difference of E2n minus En, and then we have to take the ratio of this. So what I am going to do is, just look at this side, I am going to write E4n minus E2n, and as I can see that E4n is E1 upon 16n square minus E2n E1 upon 4n square. As I have to take the ratio of E4n minus E2n and E2n minus En, so that will be E2n minus En. So if I am going to take the ratio of this, that will be, let me just, E2n will be E1 upon 2n whole square minus E1 upon n square. That will be the ratio. So that will be, if I will be just taking E1 as common, so I will be left with 1 upon 16 minus 1 upon 4 divided by 1 upon 4 minus 1 upon 1. That will be the answer, right? Now if you are going to solve it, you will see that your answer will come out to be 1 by 4. If you are going to solve this ratio, the answer will be 1 by 4. Now we have to check whether the option is available in the question or not. Okay, so if I am going to see here, I can see z square by n square, z4 by n4, z by n, and none of this. Because I am having my constant value as 1 by 4. So I will be saying that my answer is none of these, right? So we have done the question number 1. And now let me just start with the next question of the session, that will be question number 2. Okay. So the question number 2 says, when an electron in the hydrogen atom in ground state absorbs a photon of energy 12.1 electron volt, its angular momentum will be what? Whether it will be decrease or whether it will be increasing. So let me just tell you once again, we will be taking a recap of what we have covered in the chapter, right? So if we know that if I'll be showing you the energy levels, say this is n equals to 0, right? This is n equals to 1, this is n equals to 2 and this is n equals to 3. You know that if I'll be talking about the energy levels, this E1 equals to 13.6, minus 13.6. This E2 is something like minus 3.4, I think something minus 3.4. And this E3 is nothing but minus 1.5 electron volt. This I am talking about approximate values. So if you are seeing in the question that electron in the hydrogen atom in the ground state absorbs a photon of energy 12.1 electron volt. So let me just mark a difference over here. If you are going to see this energy level and this energy level, the difference between them will be E3 minus E1, that will be minus 1.5 plus 13.6. So that means definitely it will came out to be 12.1 electron volt. That means your electron has reached up to the level of n equals to 3. Why we needed this n? What was the need of finding this n? Because to find out the angular momentum, what we need is, we need a electron shell, because we know that the formula of angular momentum is nh upon 2 pi. So to find out the nh upon 2 pi, we need the value of n, and so we have find it out right here. Okay, so now we know the value of n, and what we will do now, we will be finding out the angular momentum. Let me just start with writing the angular momentum. Earlier your angular momentum was, if I will be talking about the ground state, that will be nh upon 2 pi, or you can say n will be 1, so that will be h upon 2 pi. And in this case, the second case, L3, because the electron has been moved to the third shell. So your angular momentum will be 3h upon 2 pi. So to find out the difference, your delta L will be L3 minus L1, right? So what we have to do is 3h upon 2 pi minus h upon 2 pi. So you are left with h upon pi, right? So we know that the value of h is 6.6 into 10 raised to the power minus 34, and pi is nothing but the value 3.16. So we will be putting the value, let me just write it over here. Your value will be, your delta L is h upon pi. So 6.6 into 10 raised to the power minus 34 divided by 3.16. So if you are going to solve for this,